We must be cautious when we use the EAR, effective annual rate, to solve annuities. Annuities typically have compounding that's other than annual, but the EAR, by definition, is an annually compounding interest rate. I have an example problem here, and I'll leave it to you to work through. It's kind of an academic exercise, and it shows the dangers that can happen and what needs to be done in order to use this effective or annual rate. Basically, in summary, we would first find the future value of 4 payments per year, and the future value is this annualized payment. So 4 equal payments of $100 is equivalent to $477.56. We could then effectively change the timeline here. Rather than having 4 quarterly payments, we have 2 annual payments. Now we can calculate the effective annual rate of 5% compounded quarterly, which is 5.0945. When we use that effective annual rate, our payments are also annualized. We can calculate the present value of those payments at $756.81. Let me show you how this is equivalent to what we've been doing before. So clearing time value of money, if we have 8 quarterly payments, 5% per year divided by 4 payments per year gives us a periodic interest rate of 1.25% per period or per quarter. We have $100 payments, and when we compute the present value, we get the same $756.81 as we did through this kind of academic exercise using the effective annual rate. Certainly not something I would test you on, but we need to recognize what the effective annual rate is. It is an annual percentage rate, and when the percentage compounding does not occur in the same frequency as the payment compounding, we must make adjustments. So let's talk a little bit more about what this APR, or annual percentage rate, is. This is the rate reported or required by law to be reported by borrowers. So if you look at your mortgage or auto loan paperwork, you'll see the annual percentage rate. Even if you were to get a lease on an automobile, you'll notice in the fine print, even on say a 30-second commercial, that in the fine print of that it will say something like based on an annual percentage rate of X. The annual percentage rate must be accompanied by a compounding arrangement, just like the simple rate is. And so the APR, or periodic rate, times M gives us a simple annual rate. The APR is equal to the EAR, effective annual rate, when there's annual compounding. But when we have something other than annual compounding, monthly, quarterly, semi-annual, etc., the APR does not equal the effective annual rate. And in fact, the EAR is something higher than the effective annual rate. So, some observations. Future value gets bigger as the number of compounding periods get bigger. Present value gets smaller as the number of compounding periods gets smaller. When we're comparing interest rates, we need to compare not just the interest rate itself, but to the number of times it compounds per year. So in this example here, we see that 5% compounded once per year. The present value of $100 is $61.39. When it's compounded daily, however, the present value drops to $60.66. Another way of saying this is I only need $60.66 to have $100 a year from now if my compounding is daily, whereas if my compounding is annually, I would need to have $61.39. So we can see this relationship. The number of compounding periods, as the number of compounding periods goes up, the present values go down. As the number of compounding periods goes up, the future values go up. There's a direct relationship for future value and an indirect relationship for present value. Now, on a comparison basis, that's where the EAR, or the effective annual rate, is really powerful. Now we can compare different interest rates directly and instead of indirectly. So in this example here, I have several different APRs, or annual percentage rates, and their associated compounding periods. We can't compare these directly, either from a lending perspective or a borrowing perspective, because they're not equivalent. But when we calculate the effective annual rate, we can now compare them directly. So from a lending perspective, I would want the highest interest rate possible. So perhaps looks like the 3.68%. So I'd want the 6.117% compounded weekly. From a borrowing perspective, I'd want the lowest interest rate possible. And it looks like this second option here of 6.238% compounded semi-annually would give me the lowest borrowing rate, which is 6.335. Now, where is this commonly found? I copied these from the bottom of my credit card statement. And you can see that there's different interest rates. They're all daily compounded. So balance transfers and checks, that's when I take an account, take a balance from another card, or I do some type of transfer or write a check on my account. I have a annual rate, an APR of 7.9%. That's a periodic rate of 0.021643 daily rate. The EAR, what I'm actually paying, is 8.22% per year, assuming that I carry a balance on the card. That doesn't sound like too much. When I'm pulling money directly from my account through an ATM, now the rate more than doubles. So I'm paying 20% annually as an annual percentage rate, which gives me my daily equivalent rate. On an EAR basis, I'm actually paying 22%, or a little bit more than 2% more than the APR states. So we need to be aware of these types of ideas, because they equate to real dollars, they equate to real costs when we're either borrowing or lending.